So, have you ever come across those annoying uncles who would ask you to just calculate random numbers and random things just to check how strong you are at maths? Something like if 1 kg of onion costs 25 rupees, how much will 100 gram cost? How much? Yeah, that was easy. You just have to put a decimal because you're dividing it by 10. But yeah, if the numbers get complicated, it's really difficult. And as a kid, I used to be good at it. But now it's a tap on the calculator and we're done. So then we decided that although calculators are looked at a very meh project when it comes to people learning web development, or there's no real use case that you're talking about, it's somewhere is important to put the pieces together about whatever you have learned. So today is day 9. Oh, I forgot my introduction. Hi everyone, I am Sneha from Web3 Compass, and today is day 9 of 30 days of building with Solidity. To everyone who does not know about this campaign, you can go to my previous videos, day 1, basically, where I talk about the campaign in detail and how a lot of people are doing it and absolutely loving it. Or you can head over to web3compass.xyz and check all the details. This is our challenge page, and this is day 9 where we write a SmartCalculator.sol code, calling functions of another contract, address casting, imports. So basically, we're not writing really one contract, but two. Yes, two really simple ones, and then see that how are we doing contract to contract interaction, because so far we've just been writing one contract to see how the functions and all the other things are working. So we'll build a contract that uses another contract to do calculations. You will learn how contracts can talk to each other by calling functions of other contracts. It's like having one app ask another app to do some math, showing how to interact with other contracts. Okay, so yeah, let's just go to Remix. I will zoom in. I'll just create the file first. Okay, so here we're going to write 2 smart contracts. The first one would be a Calculator.sol. Okay, and yeah. So I'll zoom in this one. And then the other one would be ScientificCalculator.sol. Okay. So for everyone who has tried attempting this challenge with a single contract, you've not done anything wrong. Trust me on that. That is how it is supposed to be. And that is how I would think about it in the first go. But then here we're trying to teach you something different. Okay. So the calculator.sol is going to be our main calculator. It handles basic math like addition, subtraction, multiplication, division. But when it needs more advanced math, it will delegate the task to Scientific Calculator. This contract is where we'll put the advanced stuff like exponentiation, that powers, square root calculations. You can go forward with doing sine, angles, cosine, tangents, whatsoever that you want to implement. So yeah, let's just get writing, right? So I've just quickly copy pasted this first 2 lines, and then I'll say, okay, contract, scientific calculator. Okay. Yeah. And what next, right? Like before, I go write the calculator.sol, I would just want you to complete this one very quickly. Now, in this one, we're just going to write 2 functions. One would be a power and the other one would be a square. Okay. Now, for people, you can parallelly write both the contracts where you just, open it in half and then go about writing it. But I want to complete one first and then just go about then how are we going to use this in the main calculator one. So I'll say, okay, Easy thing. If you have to implement the power function, it's nothing. I'll just take two numbers. One would be uint 256 base and then uint 256 exponent. Yeah, that's what the term is. And it says, okay, public, pure returns. Again, I don't know if we have talked about pure keyword, but it's exactly like view, but then it does not read or change anything on the blockchain, because whatever we're taking here is the parameter value and then just going about it. We're not storing it as a state variable, or we are not using any state variable from outside. So that is why there's no major changes or no changes happening on the blockchain. So we will make it pure. Okay. And it says, okay, uint 256. Great. So it says, now what is the condition? Ideally, AI is suggesting base to the power exponent. Great. But there's an edge case that if the exponent equals to 0, then you have to return 1. Why? Because anything to the power 0 is 1, and then otherwise, else, return base asterisk exponent. Great. That's it. Very simple, right? You don't have to put a condition for 1, because although it will return base, but yeah, even on multiplication, it would do the same. Cool. And now, we would say what? The other function that we wanted to implement was square root. Okay. So I'll just quickly write that also. Okay. So we'll use it like in a more simpler way rather than getting into very complex ways. And I say, hey, instead of uint, I'm just taking a number here. Why? Because again, I can always take unsigned integers, put a condition that I'll only take positive numbers, but what if I take negative number, right? So uint is basically unsigned integers, and int 256 is again normal integers, which can take both values. And here also, because we are not using any state variables, we say, okay, let's make it pure, because there's no reading or modification happening from outside. And then this one, I can say, okay, I can make it actually uint 256, because it will never return a negative number as a square root. And it says, okay, require, okay, if number is greater than equals to 0, fine, right? Otherwise, say cannot calculate square root of negative number. Okay, great. This condition is done. What else do we want to do, right? If the number equals to 0, then you can just return 0, because that is what the value is going to be like. Now, how else? Okay. There is this thing with the power method, and then there is called a Newton's method, which is a method where you're using approximations to do things. Okay, so Newton method says that what you can do is that you say, okay, we want the result again, what? No, uint 256 result equals to number by 2. You can implement this whatever way, right? This is int. Okay, no. So we'll have to take it as int 256 and then later convert it. Why? Because we're taking number as int 256, right? So we cannot just explicitly convert it. And then what we say is that for uint 256 I equals to 0 to I less than 10, I plus plus, Okay, what we do is we run a loop and it says, okay, see, you can see it with what AI is suggesting. What we say is result plus number by result and whole to the power 2. That is how we calculate it. Okay, so we say that once we've done checking the edge cases, we say that we will start with a rough guess that we'll divide the number by 2. Okay, and then we refine that guess 10 times using a simple formula. So if you have to say yeah, it's like more like averaging the entire thing. You can do a dry run to check, and you can also search for Newton method of approximation to find the square root. Okay, and then once we have done this, we should say return a result. Okay, because this entire thing is coming as int 256, we'll change it. Although we've already removed the edge case of it, there should not be any problem. And then we compile this, and then we deploy it. And yeah, if you provide this 2 and here 3 and call it, it says 8. And then if you provide 10, you will see 3, right? So that is how it's calculating. It will give you a nearest approximation. If you give 4, it will give you 2, right? So this is ready. This is ready. This code is ready. Now we go back to the Calculator.sol. Now what do we have to do here? What we'll do is first we'll quickly copy this. Okay. And we'll start writing contract calculator. Okay. Now, one thing that you have to do is that I explained that in the calculator code, we would go about implementing the basic mathematic functions. So one way would be that, okay, we just implement the entire thing and then just go about, just go about importing the scientific section. Or we know that, hey, you know what, in this contract, I'm just going to implement the basic thing. So I will just make sure that whatever is required, I just do that. Okay. Now, one way is that, okay, I'll talk about it in the end, right? Right now, you have to follow me with saying that now, since both the programs are in the same directory, this should not be an issue. And I'll say scientific ScientificCalculator.sol. Okay, so now what you have done is that every time you want to do something important, no, not important, every time you want to do something that is implemented in the scientific calculator, you will be able to, now that we have imported it, you will be able to see those functions when you deploy the calculator contract itself. Okay, so with this import function, we're saying that and a dot slash, we're saying that, hey, you know what, you need to look in the same directory or folder as this file and find ScientificCalculator.sol. So with this import to work properly, both files must be in the same folder. You have to really remember that both the files have to be in the same folder. The setup is what allows one contract to know about and interact with the other. Okay. Now let's see how the contract calculator would look like. Okay, again, we'll follow the same approach. We'll think about some state variables initially, see if we need an owner who's handling this calculator and what are the steps that we have to do. Okay, so we'll say, okay, we still want address owner. Why? Because like it's smart contracts. You might have to do like something very important, some important calculations. So we want only a particular person to do that. And since we are importing a ScientificCalculator.sol, you have to just assume that we're doing something really important. And then in order to actually save that address or store the address which is already deployed, we have to set the owner during the deployment. You will have to like deploy that particular contract and add the address to this one to be able to use it. So that is what owner will be doing. So we'll say, okay, there will be another address because, hey, you know what? You need to deploy both the smart contracts. And it will be scientific, calculator address. You will see why we need this. Okay. Just patience. Okay. Now we'll say, let's do our constructor. I mean, these lines should now be like pretty evident for you to just quickly write it. Message dot sender. Okay. Now what? Okay. We will say that, okay, now, since we've put in a owner section, we'll just quickly write a modifier as well. And we say, hey, you know what? Let's do this. Okay. Message.sender equals to owner, and only owner can do this action. Okay. And then you just go about the underscore pool. Yeah. Okay. Now what you have to write is that, we know that any function that is using the only owner can only be called by the original deployer of the contract. Okay. So now we'll be using this to, allow the owner to link this to a scientific calculator. Now again, it might just seem silly that, hey, you know what, this is not that important that you're setting up an owner. Yeah, okay. But imagine that you're working on a very niche project of yours, and then you have customized it to build a scientific calculation, or you're doing something like, I don't know, solving some extreme puzzle or solving a math question that has never been solved. So then you do not want everyone to have access to it. Like, come on, right? So that is why we'll keep it niche, and we'll create a function that says set scientific calculator. And what you have to pass, because we need the deployed address, we'll say address not calculator. That is confusing. And then not external. We want it to be public. Again, there's no need of external right now. And then we say, okay, did I mess with the, come on. Yeah, I messed with a curly brace. Yeah. So then this is where we say, okay, you need to specify this. What is the variable name again? Scientific calculator address. Actually, it should have been small s, right? I just copy it and paste it here. Yeah. And I say, okay, this particular address that I given has to be substituted like that. Okay. Now this part is done. Okay. What next? Like, we've set up the, once you've deployed your scientific calculator, you can just copy its address and pass it here. So this function will save that address so we can call its functions later. This is a very important step. Now, as I mentioned, there is another way to do it. In fact, there are multiple ways, how you can, how this will come into the picture, how you can call the functions separately. And then there is another simple way, which again, I'll talk about it in the end. But yeah, now let's quickly calculate the basic functions, math functions. Okay. uint 256a, uint 256b. Okay. Again, since no state changes are happening, we have not declared such variables at all. So we're keeping it pure and we say, hey, you int 256 a result. Now what is the result? It's A plus B. Come on, return a result. Great. How cute is this? Oh, sorry. How cute is this, right? This function. So we'll just quickly copy this. Boom. To make it subtract. Okay. A minus B. Do you think we need to make any changes? Okay, we'll just assume that it's the bigger number and we're not getting any negative numbers. Yeah, like, let's not get into the nitty-gritties of what edge cases will be there, because, oh, did I just delete it? Yeah. What edge cases will be there, because it will just always be there, right? Now, I'll just quickly copy this and I will say, hey, you know what? Let's make it a multiply. I want this video to be as short as possible so that you don't have to listen to my voice for like an hour. So this is simple. Again, I'll just copy this, paste it here and say divide, and then this should be A by B. Great. These are very, very simple, but you know what? I will still want to put in a condition here because this one's inevitable, which says, oh, if B not equals to 0, oh, B not equals to 0, great. Otherwise, cannot, like, come on. Divide by 0 is always an exception. We can't miss it. So yeah, cannot divide by 0. Now, I hope everything in these functions is pretty straightforward and clear for you and there's no need of me explaining it. But in case you're still finding this a problem, then you can head over to the previous videos to understand how we wrote all of this like real quick instead of just copy pasting it. Okay. Now what we'll do is that, okay, if I deploy this right now, okay, say compile Calculator.sol and come here and then see, you'll see now two options are by default coming. This was not before. When we have deployed contracts for 8 days, it was just that one contract. And then there's a way where you say, hey, you know what? I can deploy the scientific calculator also from here. I'll just remove this. Sorry. Let's just deploy it here. Okay. This is our first deployment. The scientific calculator, we'll deploy it here and we'll actually get this copied. And then in the calculator section, if you check owner, great. The wallet from which I've deployed it, scientific calculator address is 0. How do we set it? Because we have a set scientific calculator function. And this is the deployed address of the set scientific calculator. Sorry, for the scientific calculator. I transact it and now when you check it, this is 0xe0. Now if you expand it and yeah, I think the name is too big to actually show you what it is. Now, this is what we are doing here. Okay. Okay. Now, okay, the functions of it is here and scientific calculator is here. But how do we actually, get to use the functions that are part of it, right? So now I will write a function to calculate power here, but I will not implement anything. Okay, I will not implement the execution of it. I will just go about writing a function and I will show you how we call that particular function, which is in the scientific calculator contract here. So I'll say, hey, function calculate power uint 256 base, comma, uint 256 exponent. Okay. And it should be public. And this is where we want to get the return type also. So we'll say returns and what? uint 256. Okay. Now, why we made it? Oh my God, what did I do? Marked as abstract. Wait. Okay. Now what you have to do is that there is this thing called as address casting. Okay. And the next line that I do, right, is about that. I'll say, what was the variable that I've used here? Scientific calculator address. Okay. And what is the name of my code? Address. In this case, okay. So I write scientific. Oh, not this. Okay, scientific calculator. And then I create a variable name here called scientific calc, maybe. Okay. This way. Better. Okay. And then I will call it with this, right? And we say, okay, yeah, okay, it will show error right now. Let us just implement it quickly. So this line is doing something really important here. It's like you're taking a plain Ethereum address called scientific calculator address, the name that we've given, and casting it into a contract object, which is like scientific calculator here. Okay. So maybe in layman terms, you will be like, hey, Solidity, here's an address on the blockchain. I know that this points to a contract called Scientific Calculator Contract. Please treat it like one so I can call its functions. Okay. And this entire process is called address casting. You're converting an address into a contract reference so that you can just use it directly. Okay. And this only works because we've already imported ScientificCalculator.sol at the top of the file using the import keyword. And Solidity now knows the structure of the contract. So it allows us to call its function securely. So now what happens is that I'll say, hey, uint 256 result equals 2. And now I'm using this particular thing that we've created, the object we have created as scientific calc, okay, dot power. That is how we're referencing to the function, and just providing base comma exponent, which was the parameter. Okay. We're not okay. What happened? What went wrong? Okay. So why is this giving an error is because I've added a semicolon here. That is why it's not recognizing it as a function. Very smart as an error. Okay, yeah. So this is how we're making the external call. Okay. External call to the contract. Okay. Now this is done. We have learned something as address casting. Now here we are calling the function and then we return the result. Okay. Now we have a contract reference calling a function on it as simple as using a dot notation. For anybody and everybody coming from a programming background experience, I think you're familiar with it. Just like calling a method in any object-oriented programming language. Now, this will send a read-only call to the deployed scientific calculator contract, asking it to compute base base to the power of exponent, and that is the implementation that we have done in the previous contract, and then it just returns the result. Okay. Now what we'll do is we'll also use another way, which was the low level calls, right? Like without importing sometimes you would just want to interact with the code without importing its source code. Maybe you only know the address and the name of the function you want to call. In those cases, you can use a low call. Again, we've implemented this in our previous videos, which is the day 7 and day 8, where we talk about dot call, right? And how we go about it. So that is what we're going to implement here. So we'll say this time we would want to call calculate square root, okay, and uint 256 number public returns uint 256, and then okay, now again square root, similar conditions where we say, hey, you know what, require number greater than equals to 0, fine. And yeah, something like cannot calculate square root of negative number. Yeah. And then, yeah, now once we have done that, we say, hey, we're talking about something as low level call, fine. Let's encode the function call. This is like the heart of the low level call that we're talking about, and we will use something called as ABI to prepare the function call. Now, what is ABI? ABI stands for Application Binary Interface. So you have to think of it as a contract's communication protocol, okay? It defines how the data must be structured when one contract calls another. When using some high level function calls like other contract dot some function, Solidity handles the ABI encoding for us, but with low levels, you have to do it manually, okay? Okay, so now that we've written the required condition that number has to be greater than equals to 0, if it's there, it's fine. Otherwise, cannot calculate square root of a negative number. Now, because we are doing a low level call here without like really importing the source code, we're only aware of the address or maybe the name of the function that we want to call. So we're going to use something very interesting here, which is encoding the function call. And this is the heart of the low level call. And we're going to use something called as the ABI. Now, what is ABI? ABI is Application Binary Interface. Think of it as a contract's communication protocol. It defines how data must be structured when one contract calls another. And when using high-level function calls like probably some other contract dot some function, Solidity handles ABI encoding for you. But with low-level calls, you have to do it manually, and that is why we are going to do it here manually. So this is how we write it: bytes memory data equals to the built-in function ABI encode with signature. So we'll talk about the other segments in like you saw encode with selector. So there's something called as function selector that we're going to talk about, but in the later sessions. Here, what we have to provide is just the function name that we had in, what was the name? ScientificCalculator.sol. So we have square root, was the function name, and it was taking, this is not how it was written, square root, and it was taking int 256. So that is one thing, and the other part is number. Okay, so that goes as the argument here. Just quickly exit it. Yes. So now what does ABI.encode with signature here does? So it will build the exact binary format that the Ethereum virtual machine expects when calling a specific function. So in this case, we're saying, hey, you know what, we want to call square root int 256. This is the full function signature, that is the name plus parameter type. If you give selector, that is going to be certain bytes, 4 bytes, which will tell you that which function to call. But again, next sessions. And number is the value that we're going to pass as an argument here, because that is what we have taken as parameter. And then the result is a bytes array, bytes memory, that contains everything that is needed to call the function on that blockchain. Now, we've already seen how low level calls work, that previously you had to write, you had to check if the call was done successfully, and you were using something called as bool success. If you haven't and you don't know how to use the .call function, please go to our day 8, day 7. That is where we talk about in detail. So we will quickly write, we're expecting a Boolean value, the success message, and then we pass bytes, memory, again, return data, because we're expecting a certain return type here. And what will happen is scientific calculator address dot call data. Okay. So, understanding it again, this here we're telling the Ethereum virtual machine that, hey, send a raw call to this address using the encoded data that we've just created. .call parenthesis data sends that data to the address stored in scientific calculator address. Now for day 7 and day 8, we've talked about that if you're sending ether using .call, we were saying payable message.sender .call and then the value as parameter. And then there would be a asterisk which goes as encoding, okay? Function encoding, or if you're sending out to like a contract instead of an address, right? So here, scientific calculator address again is the address that we're talking about. And this data is what will be sent to this particular address. And it will return 2 things. One is success, a boolean that tells us that the call has worked successfully. And then other would be a return data, which is a byte array that holds whatever the function has returned. Okay. Now this is like calling a function manually through the back door. Like you need to get everything exactly right. And then, okay, let's, now that we've used the .call function, we're going to quickly check with a require condition if it went through. So it says success, external call failed. Okay. So always whenever you're writing error messages on your own, please make sure that you don't use like repetitive things so that you don't know where the code actually stopped working. Okay. So you always have to check if the call worked. If something went wrong, like wrong signature, wrong address, function not found, success will be false, and we stop execution with a helpful error message. Now, the next step would be that we've sent an encoded data. Now we need to decode it. Okay, so we will store it as part of a result. uint 256 result, again, abi.decode, return data, uint 256. Yeah, exactly. That is how it is supposed to be used. And then it says a return. Oh, how did I switch tabs on? Return result. Okay. So for this function, you will see that, the result or the value that you get is not going to display like we do for other things. That is because we're using abi.decode here. So we take the raw return data and decode it back into a usable value, in this case a uint 256. Since we know the return type of square root is int 256 and we are returning it as uint 256 here, you might just choose to adjust this depending on how you handle those signed values, right? So make sure that you give or assume that the number passed is safe and positive. If you want to add more conditions, edge cases, feel free to do it. And yeah, so I will just quickly compile it. Yeah, that was Calculator.sol. Great. So now here you are looking at you've already figured that we have scientific calculator, Calculator.sol. So we'll deploy both of them. this also, deploy, great, copy this address, and set scientific address, and then you set it. Okay, great. We've already looked at, even if we don't, I think add function is pretty much very simple for you to go about. Power, divide, multiply, you can play around on your own. Now, the calculate square root, as you see, if I give here 4, right, and transact, oh my god, where's the response? Here, in the terminal, when you open this, you will see that the decoded input is uint 256 number is 4, and the decoded output is here, right? That is why, that is what I said that, when we are sending encoded and decoded data, we will quickly try this as well, and everything else will work fine. Now, this is definitely a way to do it. But the thing that I've been talking about is that there is, two ways that we have not talked about. One, I think I mentioned, is the delegate call section. Now, that is extremely lengthy. And that's a whole thing in itself. So we'll talk about it in the later sections. But the other part, which is something that you would have probably thought of in the first instant, and I would have also thought about it, is writing both the contract in one contract. So I know a lot of you must be thinking, Sneha, you could have just told this in the start. Why now? Yes, because I know you guys are smart enough to write both the contracts in one, and it just takes a compiling and deployment for you to figure out that it worked. But you would not watch the video, you would not look at how we do cross-contract communication, how are we using .call to call the other functions, how are we performing external calls, and all of that. So that is why. But I will quickly show you the combined Calculator.sol. Again, just plus. Okay, so I've already copied the same contract. Now, one thing that is missing here is the import statement. We don't need it because the scientific calculator contract is here itself, and I have absolutely made no changes here, no changes at all. And then when you see compile, woof, it's done, right? And then you go to, let me quickly delete this. And then you quickly go to this. So you will see now you have two forms, calculator, combined calculator.sol, and scientific calculator, combined calculator.sol, right? Because you have two contracts here and the compiler knows it. So again, you will deploy it as it is, calculator also deploy, copy this address, and then just go about setting the scientific address according to that. And then if you calculate power 2, 3, 8, everything else will work like that. Extremely simple. Again, here, come in the terminal, look at it, and here is your decoded output, right? So that's it. So as of now, you've built two contracts that divide logic between basic and advanced math. You can definitely use this segment where you're writing two contracts under one, but imagine you're building real world applications and one contract is like 700 lines. Now, you cannot expect yourself or anybody or as a good practice or as a good developer to write the next set of contract, which might be 500 lines in the same file, right? That is why you might have to deal with multiple contract files, and it will happen when you're working on a real world application. So it is very important that you know how to do cross communication between contracts and which is the method that should be preferred and all of it. But now you know how to talk to different contracts using both high level calls, low level calls. Delegate call is left, showing how to modularize logic and keep things very, very organized and not make it extremely messy or lengthy. And we are talking about safe practices like access control, error checking, and all of that. But I think that was pretty much it. Happy building, and I will see you for day 10. See you guys.